How's it going again, ladies and gentlemen? Mr. Johnny here, talking about solving titration equations. We want to be able to solve titration problems where basically we have an unknown acid or an unknown base, and we want to figure out what is its concentration. All right, so let's talk about a little math, everybody's favorite, right? So the questions will be like, how much acid do we need to neutralize X amount of base? So it depends on a couple of things. It depends on how much acid and base you got, and it also depends on the concentrations of the acids and the bases. So we know that we're going to have to take a look at these things. So neutralization is basically just when you're getting H plus equal to the amount of OH minus, the amount of H pluses you get from the acid and the number of OH minuses you get from the base. All right, well, where did all the H pluses come from? Well, if we had a mole of acid, we'd have a mole of H plus, right? If I had 1 HCl, 1 mole of HCl, you get 1 mole of H pluses. But what if I had 1 mole of H2SO4? How many H pluses would I get then? Well, this 2 is saying that we got 2 of them. So it would really be 2 moles of H plus. So we got to look at how many moles of the acid we got, but also how many H's we get from each mole. Same thing is true for the OH minus. If we had NaOH, we would get 1 OH. Whereas if we had like MgOH2, well then we would get twice as many OH minuses. So we got to account for those things. So it's really the moles of the acid that we get times by the number of H plus that's given off by each acid. Right? H2SO4, you get 2 H pluses. The same thing is true for the base. You want to look at how many moles of the base do you have times how many OHs do you get from each base. All right, so now my question is, well, how do we figure out moles of acid if we know the volume and the molarity, right? You got to remember that molarity equals the moles per liter, or it's moles per volume, right? So if I wanted to get moles, I would have to do the molarity times the volume. The same thing is true for acid or base. So we want to take a look, molarity of the acid times the volume of the acid will give you the moles of the acid, right? Times the H plus that you get. And for moles of base, it's really just the molarity of the base times the volume of the base that you use. And then again, you got to account for how many OHs you get from each thing. So a simplified version of this would be number H plus, ma va, equals number OH minus mub vub. So the ma va is the molarity of the acid times the volume of the acid has to equal the number of OH minus that you get from the formula times the molarity of the base times the volume of the base. So let's take a look at a couple problems with actual numbers, all right? So the first question is, how many moles of LiOH are needed to exactly neutralize 2 moles of H2SO4? All right, well, we know that the moles of H plus has to equal the moles of OH minus. All right, well, let's take a look here. This is our acid. So let's think about this. We got 2 moles of H2SO4, and we'd have to times that by 2 because we get 2 H pluses for every H2SO4. Well, that's going to have to equal the moles of OH minus. All right, well, if we have that 2 times 2, that gives me 4 moles of H plus, has to equal 4 moles of OH minus. All right, well, how do we get 4 moles of OH minus? Well, we have a certain amount of LiOH times 1 OH minus for every LiOH. So basically, if we want 4 moles of OH minus, well, we need 4 moles of LiOH, right? Now, what would it be if instead of LiOH, let me erase all this, what if it was MgOH2? What if it was MgOH2? Well, then it would be moles of that stuff times by 2 OHs for each one. And what would you get when you solve for moles of OH or MgOH? You'd have to have 2 moles. All right, here's a different problem. If it takes 15 milliliters of 0.4 molar NaOH to neutralize 5 milliliters of HCl, what is the molar concentration of HCl? All right, so let's start labeling things. Milliliters, that is a volume. This is a molarity, and it's of NaOH, so I know that those are for the base. So I got my MUB and my VUB. Now this 5 milliliters is a volume, HCl of an acid, so that's my Va. What is the molar concentration of the HCl? So it's asking for Ma. So we got number of H plus times the molarity of the acid times by the volume of the acid has to equal the number of OH minus times the molarity of the base times the volume of the base. All right, well, this is the only thing we don't know. Right, so how many H plus do we get from HCl? Just 1 times the molarity of the acid, what we're going to solve for, times the volume of the acid is 5.0 milliliters. Now, since this is a proportion, we can leave it at milliliter. We can leave it in milliliters, and our answer will be in milliliters. So how many OH do we get from NaOH? Just 1. So it's 1 times the molarity of the base, which is 0.40 molar, times by the volume of the base, which was 15.0. So I'm going to plug and chug now. And I probably should have a calculator handy, you know? So I get 5.0 times Ma equals beep bop boop. Calculator. 0.4 times 15 equals 6. Solve for Ma. So we do 6 divided by 5, and we get 1.2 as our molarity of our acid. Final answer. Take a look at another problem. How many milliliters of 2 molar H2SO4 are required to neutralize 30 milliliters of 1 molar NaOH? So let's backtrack. All right, so we got a molarity here, H2SO4, that's my acid, required to neutralize 30 milliliters, that's my volume. 1 molar, that's another molarity, NaOH, so they're both for my base. And the thing that I'm asking, or what they're asking, is what is the volume of the acid? So let's plug it in. Again, we got number H plus times Ma Va equals number OH minus times MUB VUB. All right, let's plug and chug. How many H pluses do we get from H2SO4? 2. So it's 2 times the molarity of the acid, which is 2.0, times the volume, which is what we're solving for, has to equal, all right, NaOH, we get 1 OH times the molarity, which is right here, 1, times the volume of 30. So now I'm going to, plug and chug some stuff. I get 4.0 times Va has to equal 30. All right, and I'm using milliliters, so my final volume will be in milliliters. Solve for VA, divide each side by 4, and I get, what, 7.5? Yeah, I get 7.5 milliliters. Now we can also do a check, right? Now I have 2 molar H2SO4, so this stuff is really concentrated. I get a lot of H plus, whereas NaOH is only 1 molar and I get 1 OH minus. So the acid is going to be more potent, so it should need less acid than the base because it's more potent. It's a higher concentration and I get more H pluses from it. So that makes sense. That 30 milliliters of base only needs 7.5 milliliters of the acid. That's everything. I will see you guys in class. Bring questions. We'll get plenty of practice in it. Rewatch the video if you need. I know a lot of people struggle with the math. Rewatch it, pause it, look at other problems, bring questions in class. See you there.